My name's Grant Strassel, and I go to Hamlin Robinson School, and this is my science project. This year I built a fuel-propelled levitating superconductor around a rare earth magnet track. This project was beyond awesome. Playing with magnets was cool, but levitating superconductors took it to the next level. This experience is something most people don't get to do. I hope to continue my work and find a fuel source that will propel the superconductor. This video is an explanation on what I did. I hope you enjoy it. Rare earth magnets are a very strong magnetized alloy. The poles run on the top and bottom instead of the ends like other magnets. The ones here have a pole force of 12 pounds each. That is one strong magnet. They were actually a hazard to my fingers and broke and even sparked when they snapped together. So this is a magnet separator, and without this we can't separate these magnets because these are really hard. These you can maybe get off, but these are really hard. You can't really push them off. So we use this to cut the magnets. So and here it works. It goes up and then it goes down and it pushes down and you get your magnets and then it falls down. Now you gotta move this out of the way because then the next magnet will attach to it if it's not out of the way. An additional safety issue was that they tended to lump together after being separated. I found that sticking them to a metal track kept them in place. So I fashioned a circular metal track using tin snips and a hammer. And then laid out the rows of magnets. The superconductor locks in a field that is one field. Now this is north and this is south. So we can't have the superconductor when it goes from here to here. It locks and so it can't move. Now in this we have south on the outside and north on the inside and south on the outside. And so the superconductor can move easily. Now my track is complete, see? So here I'm glue gutting this opening is because the liquid nitrogen will go out, so I'm making sure that it will not come out. Hello, this is Grant again, and what I'm making right now is the case for the superconductor. Now I needed a foam lid, but what was wrong with it is I'm going to put a rocket cell on top, and the rocket cell is hot and it will burn through this, like this. So we know that this burned out, so it's not good that we have the rocket cell in there. So we need to build something on top of it. Here we have a Kevlar glove, and so we're gonna try it is because it needs something to insulate the rocket cell. Don't have any burning going on. So there was no warning going on. It looks like this material will work and it will help to insulate from the styrofoam. Now it's time to test the superconductors. So here I'm mounting the superconductors in the case. So I am putting them in and I'm making sure that they are level and straight. So I'm going to fill this up with liquid nitrogen, and it lasts about 2 minutes and 30 seconds. And so what happens to that liquid nitrogen is it evaporates into a gas, and how it does that is because liquid nitrogen is lower than negative 350 degrees, so it evaporates and becomes a gas. So these are our superconductors, and this is our test pack. See? And so we put liquid nitrogen in there, and so I'm going to put this cap on. So this is our insulated foam, and so we're going to put this in here, and we're going to fill this with the nitrogen right here, and we have this, and this will lock itself in the magnetic fields. It's locked in position because see, it's moving, and I'm moving the cup, but it wants to stay. Wow, isn't this cool? Here I am at the park, and I'm going to do a test with a rocket cell, and I'm going to see if there's any negative effects with the rocket cell and the liquid nitrogen in the bottle. We figure that we wouldn't have done this inside. I wrapped the rocket cell in Mylar, and I've connected up the normal thing because this keeps it hot, and so it burns. Now I'm going to strap it to the liquid nitrogen container. Now we need to fill the container with liquid nitrogen. Let's get to the test.
4, 3, 2, 1.
Went up the side, and I don't know where it went. It must have went way over there. Well, I think it might have maybe reacted. I don't know. Unfortunately, I think that my science project is over is because the rocket cell will be a little too dangerous. So I might have to think of something else too. This is Granite signing off until next time. Wow, isn't this cool? Levitation is so cool, isn't it?